Hi, in this week we will review some approaches to identify motion on images. But first, let's talk a bit about what can we measure and what we cannot. When we record a video, we are basically taking several pictures, one after the other, capturing changes in the scene over a period of time. But any change that we capture on the image can be associated with different things, and also can have a different effect in our perception. Remember that regardless of what is happening in the real world, the image is just a set of intensity values that do not need to reflect the real physical phenomena that is happening in the other side of the camera lens. And that is evident in the following examples. Imagine that we have an object under certain illumination, like a spotlight in a theater. Then we change the position of the lights. This illumination change does not represent a movement. The object didn't move at all. However, we recorded video of the object. On the images will be a drastic intensity change that can be interpreted as motion. Another example. We have a sphere of a smooth solid color floating in the space. And now I will make it spin. Can you see it spinning? If the sphere had a different texture or a mark, we could see it. This is another case in which what we see on the image does not necessarily correspond with the movement in the real world. We can also see objects that are moving and that the perceived movement does not correspond with the real direction. This is the case of the barbershop pole. We know that the pole has a rotation, so that the information in the pixels should move in the horizontal plane. However, the perception is that the movement is happening vertically. Finally, we have images in which there is no movement. There is no change on the illumination, but yet we perceive some movement. These are called optical illusion, special patterns that trick our visual system. These kind of images are completely stationary, and the apparent movement happens due to small adjustments in our eyes when we fixate to certain patterns. Optical illusions are cool, but they have no effect on the approaches that we will see in this class. For a computer, there's no movement here because the image values are not changing at all. Okay, so now that we know all the different scenarios, let's start with a simple example in which we know that things are moving and we can see it on the video. We take two video frames that are just two images and we compare them. In the areas in which there are no movement, the pixel values remains constant, no change at all. However, in the area in which the object moves, we will see a change in the relative position of the object, and therefore a change in the intensity values of the image. A simple approach to measure this motion is to find the new position of the pixels that move between images. Similarly that we did on simple stereo, we can use template matching, creating a window to get a pattern and then look for it in the second image. However, in this case, there is no constraints for the search. The objects can move in any direction, so we also need to search in both in X and Y axis. We can create a region of interest around the location of the window in the first image and search in the second one until we find a match. In this way, we can avoid searching all over the image. Once that you find a match, then you will have a vector that tells you the direction and longitude of the change of that particular window in the image coordinates. Remember that if you want to know the movement in the world coordinates, we need to use a binocular system. This approach is a bit limited and can be really slow, because we need to search all over the image several times, and in the same way that in other methods, the window size that we use can have a deep impact in the result. We need to add that if the object is moving fast, the displacement will be larger in the image. So then it's possible that if you are using a small region of interest to save time, then you won't find a match, because the pattern that you're looking for is out of the bounds of your ROI. Another problem can arise with depth. Imagine that the object is moving away from the camera. So in the next frame, the object will be smaller in the image. Then, template matching will eventually fail to recognize the pattern because of the size change. So in the next video, we will see some approaches to solve these problems. Okay, in this video, we talk about motion perception, different challenging situations to detect motion, and how to use template matching in simple scenarios. See you in the next video.